Welcome to another movement organizing live stream. I'm Ryan Hoffman, talking to you from Treaty 7 territory, also known by its settler colonial name of Calgary, Alberta, Canada. Very happy to be here today, putting together trying to put together anyway, some fairly diverse threads, following up with some writing and thinking I've been sharing lately around the, I guess, theoretical biology would be the thing that brings the ideas together. And today in particular, like any Thursday live stream, I'm trying to make things more relevant to people interested in somatic education as a not just as a practice for individuals or people that are teachers of these various practices, but also in the context of the larger movement that I feel these practices, these educational movements themselves fit into. Namely, a strategy for civilization as we know it, like the group of humans that are alive on Earth right now, with all their various power imbalances between them and complicated histories and identities, that that system can improve itself through self-reflection and not necessarily just through a kind of rationalist, like enlightenment type lens, although many of the people that develop these ideas fit into that kind of modernist optimism about the progress of people as a group, people as a species. This appreciation that there's something like a cultural evolution to humanity, and that you could look at our current state of affairs as being in a kind of maladaptive state, a kind of backwater from an evolutionary sense, um, and that however we find the right parts of ourselves and we find the right processes to bring forward a community of people and all organisms on Earth that thrive together, that support each other enough for thriving, is an ambition that I think is thoroughly supported, thoroughly underlying the various educational movements that we call somatic education. But I've got my own, synthesis of how this all comes together. I have my own life as a research scientist and my own interest, albeit mostly self-taught in theoretical biology, and then my own training and work as a Feldenkrais practitioner. So the school of somatic education called Feldenkrais method is something I'm actually engaged with vocationally. And so that's the background. That's what's being sort of drawn together today. And so here are the two main threads that are being drawn together. This idea of somatic education and its relationship to biological functions, and this problem of specifying biological functions and what we can do about this problem. And then the concept of information processing as may be the right framework for being able to get at the relational biology, not focusing on the movement of the matter necessarily, um, or even focusing on the parts of the matter that are attributable to human organisms, but tracking the informational status of the organisms, um, or maybe not the organisms, but just the functions themselves. Um, Thinking perhaps of the organisms all as being part of soma, one continuous, self-aware uh, tree of life. And so I guess it's kind of a bug, but it's also a feature of the kind of thinking that I'm developing, that the long-standing problems in theoretical biology, like the species problem, um, sidestepping, sidestepping the species problem. What is a species? And the kind of fractal uh, emanation of this, the projection of the species problem down down to the problem of the individual. So in a sense, those aspects of life get rather smeared out with the approach that I'm developing. And so that's either alarming or attractive, depending on your perspective. Um, but suffices to say that just like in the origin of species, Darwin doesn't define what a species is. He's very clear. Here, here, I'm interested in addressing how individuals such as ourselves can help other individuals, general members of the public, um, come to um, a better negotiation, a better reconciliation of the various tensions that are made clear in the various contexts of the somatic crisis. So the somatic crisis is like one one sort of large introductory thing I think I want to motivate as a general idea, um, as the context for what somatic educators are actually clarifying. We're working with Soma here, Soma in the as I almost always use it, in the Thomas Hanna sense, um, the experience of the living body. And so really taking all those words together in those quotes as the thing that's in crisis, then the somatic crisis I propose as a larger umbrella to contain things like the mental health crisis, the environmental crisis, so-called environmental crisis. It's not really one thing. Um, putting together things like settler colonialism, uh, patriarchy, uh, religious expansionism, um, like conquest, religious conquest. We have various just disparity, social disparity. So we can say the crises of social disparity. Um, to name a few, um, you can think of aspects of health, chronic pain, chronic pain crisis related to um, drug drug abuse crises, alcohol abuse, methamphetamine abuse, opioid abuse, cannabis abuse. Why not? Um, so I'm suggesting that all these things can come together um, in a way that maybe is coherent, maybe is actually intelligible, and gives a framework for making progress in what seems to be completely disparate areas. And 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 for this point in if you're following me so far, then I'm not asking that you agree that this is a useful term, but I ask you to agree that it's ambitious, that what we think of as mental health and what we think of as the environment, um, we think of as different issues, and completely different schools of expertise go to these areas. And you might be like, yeah, I guess this is an example of, a smart person thinking that they've got like a synthesis that addresses a lot of really different areas with a lot of expertise in those areas. And so the first thing I need to emphasize is that my scientific expertise don't credential me for this conversation that you're about to hear. In terms of like my actual training and experience, it's in structural biochemistry. It really is very hyper specialized in a different area, and I'd be more qualified to talk about quantum mechanics really than to talk about mental health. Um, so so I am more qualified. So that's something to be clear, is that um, I'm not trying to arrogantly trammel upon all these very different areas of expertise, but I'm offering that there is a line through this that comes together in the ambiguities between, well, basically all the ambiguities in the usage of the term function, because it's hard to define mental health if you're a mental health expert, but however one does it, it tends to have an aspect of functional thinking in it. That if a person has sociopathic tendencies, but they're in a corporate ladder climbing environment, then that selects for those behaviors, and it's very adaptive. That those traits in those environments can lead to those individuals thriving, at least in their little local bubble. And so as a result, mental health professionals kind of have a universal, well, is it interfering with your life kind of recipe for whether or not a trait or characteristic is pathologic. And then so that interfering with your life recipe is encoding this functional, it's sneaking in this idea that if it works for you, is it a problem or not? And I'm not saying that as like a criticism of mental health workers, but just as like pointing to something about the theory of the underlying theory of when a person's behavior is becoming pathological, when you could say they're mentally not healthy, they're mentally ill. That those criteria tend to have a functional a functionalist measure of quality. And so then there's another aspect, like, so then putting that aside, take the environment. Well, we've seen, for example, that the idea that making changes to the environment is damaging to it can be undermined with enough propaganda. That there's a large number of people, you've probably yourself found yourself on one or the other side of this conversation, where somebody points out that carbon dioxide can't be something to worry about putting into the atmosphere, because if you go back far enough in geological time, then the atmosphere was mostly carbon dioxide, and it was all plant food. And so plants evolved and used all that carbon dioxide and made the oxygen atmosphere in the first place. So why are all these I don't know, brainwashed intellectuals going on about global warming? Goes the propaganda. And so it's this idea that carbon dioxide has a biological function that's well established. So how can you call it a poison or something toxic to put into the atmosphere? And of course, it's a stupid argument, but it's effective in a way, because it uses a couple seductive, fallacious ways of thinking. For example, the naturalistic fallacy that just because something occurs in nature, it is a good thing for to happen. So, like, making reference to what the Earth was like billions of years before animals existed is dumb, out of context kind of thinking. But it shows that if you can come up with a function for something, that you can distract people. That thinking about the function of carbon dioxide is a way to distract people from the fact that we are definitely perturbing the atmosphere in a very short time, a very large amount, in a way that's unprecedented and is predicted to cause very bad effects that are apparently being confirmed now. So that rather simple explanation, people can get distracted from it by getting snowed with these quasi-functional arguments, making these arguments about the function of carbon dioxide. It's not a pollutant, it's plant food. So by shifting the telos, by giving a different goal associated with the putting of carbon dioxide into the atmosphere, you can really distract people in a convincing way. So I think maybe I'll take a run at a third kind of motivating example that bridges the chronic pain and drug abuse crises, say the opioid crisis, or you could say crises. And again, I'm not a therapist. I don't provide pain relief to anyone except trying to manage my own situation. Um, but but there's this idea that pain is something which can be treated with a molecule that you take, and to the extent that it's phenomenologically correct, to the extent that if I'm a doctor and I'm dealing with patients that have all kinds of sources of chronic pain, and I know that giving them this pill will make their symptoms go away, it really seems like there's a function associated with the pill. And certainly we need to think about the function associated with person in pain comes to a doctor seeking relief. That very first part of the whole exchange, where the person that's suffering seeks out help, something that somatic educators know about because we engage the public in similar stages of query, similar stages of uncertainty about how to make progress for themselves. And so it's this investment in the function, in the way that um, patient compliance, taking the drug, following the doctor's instructions, leads to a change in their physiology, which leads to the symptoms being relieved. Um, Overinvestment in the concreteness and the fixed nature of the relationships that cause the pain relief to occur in the first place is also the reason why the long-term management doesn't work out quite often with that kind of treatment. um, and and any sophisticated use of medications needs to think about how to introduce them into the patient's soma, and how to um, deal with the long run consequences of that, whether it involves needing to come off the drug or if it involves being on this supportive molecule for the rest of their intended existence. Then there's still going to be somatic consequences. This person is going to have all kinds of different social relationships, different kinds of life relationships, functional relationships, that secure access to the drug, that rationalize the dependency, or that maybe creating distance from rationalizing the dependency causes other behavioral adaptations. At any rate, there's going to be some effect of a long-term introduction of something like a drug in a person, and thinking about the intended effects is a big problem. Uh, hey, I got this little bit of viewership here on Vaughn. Um, let's see what Square Balls has to say. Right. So, well, we need a socialism, this person says. If you're adapted to the shithole, you're friggin' insane. And there's a lot to that. And so that's a lot of the toxicity of mental health, practices, or a lot of spiritual bypassing as well, is this just accommodating whatever shitty thing is going on. So, yeah, I completely agree that reorganizing our society on a large scale is the kind of thing we need. And the problem is that we're atomized into individuals that don't know how to find that right kind of organization. So I kind of politically agree with what uh, Square Balls is saying there. Um, but that it doesn't mean I know a simple recipe. I mean, like I just so, how to get there is entirely the issue. And in these particular live streams, I'm mostly focused on communicating with people with similar background to me, that are working as somatic educators, trying to actually help people do certain things more comfortably. So Feldenkrais practitioners will work with people with chronic pain, or people that are like performing artists that are trying to be more expressive. And this ambiguity in what functions are, again, touches on um, the wide range of actual applications that Feldenkrais practitioners find for their work. So it's in the broadness of what soma is. It's in the multiple ramifications of this somatic crisis, if you like, or you don't have to use that jargon. But I do think um, having a better understanding of life itself, um, and soma, what we mean by soma itself, helps with the clear framing of how to actually approach helping people with this information. So to review, there's a number of cultural terms that are very pervasive, and they include body, and this larger thing is the environment. We've got other things. If you're just looking at this, you wouldn't know the person's alive necessarily, but we can show that they're conscious, that they're aware of their own situation, because we can have a thought bubble. We have a little peek into their private life, and this person's aware that the sun is shining on them, and so this aspect of the picture, you have a word for, called the person's mind, their mentations. All right, so we've got these three aspects. They're not three aspects. We've got these three different labels for parts of the picture. I just drew a picture, and I can label these three parts of the picture. The first thing to say quickly is that to describe a function, at least one that you intentionally do, then I suggest you need all three components of this picture to describe a function. I'm gonna motivate that more explicitly in a slide or two, but this is in terms of definitions, what we mean by the word soma is all these things coming together. It's at least the experience, the subjective aspects of body, mind, and environment that are coming together in the living person, that are actually experience. It's the experience of body, mind, and environment. Okay, that's the actual thing that we're talking about. So, how could it be educated? Well, people like Feldenkrais are clear. It's not like the teacher can make it happen for the student. So that's one thing, is that what somatic education is culturally is there's teachers that relate to students, that communicate with students, and in so doing, they can suggest courses of behavior through which the student enriches their own soma or clarifies their own soma. So that's one answer. But it doesn't necessarily help us apply it to any specific situation because it's a cartoon and these are very general labels on this cartoon. So maybe making things a little bit worse before they get better, or before I leave it disorganized, as is, I guess, also a tendency for me. I want to clarify, I want to emphasize that thing I said, that to talk about a function, we need all these things to come together. And there's different trains of thought that you can use to support it. You can, although I'm not interested in citing Aristotle very often, because other people are still talking about it, I think it must have some actual holding power, that these four causes, it's one way to connect with the idea of soma, because to actually be able to specify all of the four causes, especially the final cause, you need to think about who is it benefiting. There's something relational hidden in those four causes, in the sense that the purpose of a particular process is a function of an agent, which Aristotle is comfortable just introducing as maybe God or some outside influence on things. So, in that sense, the final cause of the movement I just made was transferring the liquid to my mouth and drinking. And that's because that's what I decided. But maybe I'm doing that like emotionally. Maybe, like, why did I decide to drink that right then and there? The coming up with all the meanings and all the implications of a person semi-habitually drinking something while they talk to a camera. It's a complicated story, actually, to get it right. And I don't think that it's a level of complexity or detail that can be easily sidestepped. Um, but in the sciences, I just got a. I just noticed a bad text message. Actually, I need a minute here. Okay, excuse me. A little bit of a family emergency there, and yeah, how could I dissociate myself from all my social relations just to talk to this computer? It doesn't make any sense. So you can look into that kind of you can take that angle, but um, I'm gonna take the approach of looking at simple machines, which I guess it also occurred to Greek philosophers. Um, and the simplest machine I can think of is like an inclined plane. But the thing about um, it's always a little distorted. Oh, no, this is screwing up. So if I just gave you this shape, it's like a wooden wedge. I didn't even tell you the size of it or anything, the scale. Then and just asked you, what is its function? What is this object's function? I said it's an inclined plane, but if you're just looking at the shape of it, it's not at all obvious what to do with it. You know that you set it up on a surface, gravity, gravity directed downward, and that you introduce other things like a block. that you introduce other things and push them up the inclined plane, and that it's a device for elevating the things so that they can get transferred onto a platform up here. You can't see that from just looking at the original inclined plane. And so whether you're lifting with it or lowering it, or whether or not it's not actually an inclined plane at all, whether it's being used as a whole other type of machine, like a door stop, or maybe it's a part of something that doesn't have any functional significance because it's broken off of a larger thing, like a tooth on a saw. So just looking at the structure itself isn't enough to get at the actual idea of what is the function of this thing. And this is going to show up over and over in biology. Similar problems. You can have a biological structure looks like a femur. What is the function of this biological structure? You can definitely go into anatomy and physiology. Maybe some of you hear that question and you just immediately um, go to, was it a human femur? What is the person using the femur for? What activity is it participating in? Then we can start to describe an answer to it. But yeah, the problem with biological functions is even larger than that question of physiological function or anatomical function of a particular tissue. I'm trying to find the picture. It's like I can't find it quickly. There we go. Well, if the biological function of the femur is to support walking or some kind of function like that, then what about this possible event in human evolution as depicted in Stanley Kubrick's 2001: A Space Odyssey, where one hominid like ape thing discovers that a bone, a femur say, can be used as a hammer, can be used as a tool. It'd be pretty ridiculous to say that the femur evolved to be used as a hammer by some other organism. That can't be the story. But equally, it can't really be the story that the kind of thing being depicted here is a step outside of biology, outside of the natural world. This takes us to the concept of two natures. Murray Bookchin is where I know the idea from. I'm not sure where where uh, where the where else the idea is presented. Um, but there's this natural world that we are part of intrinsically, and that can't really be um, contested. But then at some point, humans create a distinction. Humans create their distinction of um, the natural world and the artificial world, and that boundary is not clear at all objectively, um, and yeah, to the extent that it's a requirement of being humans that we look at the natural world in this way doesn't at all seem clear. Seems that there's plenty of other cultural contexts where this distinction between first and second nature might not even be made. Um, but if the function of a femur is to walk, then this can't be functional behavior. And if this isn't functional behavior that we're looking at, then it certainly wouldn't make sense to call it an adaptation. It just doesn't fit all the normal uses of the word function. That as this monkey goes around bashing other monkeys and setting up a whole new new stage, whether or not you understand that as a purely cultural evolution or as something which is then going to cause or facilitate a series of adaptive biological changes that get genetically propagated, and so therefore, bona fide evolution. Um, the those details don't really matter. There's a historical thing that changed here. Before, this group of monkeys didn't have the the hammer use of a bone, and then we're watching this moment, and now after this moment, this group of hominids is going to have tool usage in this way and domination through tool usage as a part of a dynamic in this group of hominids. It's not it's not anthropology, it's art, it's not evidence, but it's a hypothetical moment that almost necessarily happened, just like how our ancestors must have acquired fire making and um, all the fiber crafts that are poorly documented um, in favor of all the metal and stone crafts that are associated a lot with uh, uh, certain categories of tools that overlap with weaponry well. I forgot where that sense is going. Um, but all those all those artifacts that we associate with the evolution of modern humans, they reflect this reality that it's better to, if you're going to do something destructive, why not use a tool for it? Why not, if you're going to bash your hand against the ground, why not bash something else instead that won't that will take the damage or that maybe is more resilient than your own structure? This ability to use tools is the same thing as the ability to function as a human. I, I'm just gonna state that as like um, a fact. I can't prove it, but as Feldenkrais practitioners, that's very much the kind of theory that Moshe is laying out in Body and Mature Behavior. This that a given developmental process comes to fruition through coordinating previously developed processes in a way that's intentional, that's actually goal directed, it makes sense, and it actually accounts for what you see children doing as they self-teach themselves um, movement and doing all kinds of intentional things. So I'm going to pause then talking about functions, other than to say that we can't talk about them in terms of bodies. We need to talk about them in terms of this coordination between bodies, intentions, or whatever the experience of body is for that person, and and that person's experience of environment as well, and then the actual environment. Those those components need to come together to describe any function. The function of walking on the ground, whether or not you know that femurs exist, the ability to coordinate a femur to walk on the ground involves orientation, sensation that there's ground, understanding of all kinds of things about orientation and gravity, the nature of the terrain itself, then the actual voluntary movement of the muscle groups that are attached to the bones that uh, cause the voluntary movement to change the relation between the experienced inputs and the surroundings. So that's a built-in bone, and operating it as part of one's leg. Or just as easily, a person can reach down and grab a femur that's been decomposed out of some previously deceased organism and hold this femur and then swing it with the intention of hitting another thing with the end of the femur, getting leverage and also protecting yourself from the impact. Two uses of a femur, and both of them are functions. And if one of them involved, you know, making a living, a vocational movement, striking an object with the bone, then very well a somatic educator might be asked to enter the picture and help clarify for the individual something about the situation. Hopefully, hopefully this is resonating a little bit, at least, that the ambiguity of function is real, that we need to think about more than just bodies or parts or structures, but we need to think about how these things coordinate with respect to intentions and the surroundings for movement to be functional. Because otherwise, when I go like this, all I need to do is be looking over here and then do the same functional movement with my hand, and now I've just poured the drink onto myself. We would probably call that an error, something which isn't functional. The kind of thing a person wouldn't want to do without an intention behind it. And then again, if you had an intention behind it, that silly behavior could actually recover some kind of rich context. And so that's the problem of functions. It's a real problem. And because context needs to be included in describing it, there hasn't been, I don't think, a lot of progress in physiology really clearly describing what functions are. So that's, oops, I was on the whiteboard there. Oh yeah, you didn't need to see that. Okay, so right, take that off, go back to here. So this is an article which was very influential. You can read it on archive. It's a short article. It doesn't make a lot of simple predictions that can be directly checked by experiment. It's more of a paradigm proposal. It's more of a theory paper that's saying one one might benefit from looking at life phenomena this way. Hmm. That's a good deal with my notepad there. Never mind. Right. So I'm just going to review some things from this paper. Am I? Right. So starts off with this question: what is life? Introduction: what is life? I have to close this. I want this thing there. There we go. So starts off with this question: what is life? I can't read that without drawing reference to Schrodinger's great little book in from 44, where the rule of information is something very much that Schrodinger is arriving at. Using more mostly thermodynamic type arguments to come up with a proposal that information is important. Doesn't doesn't quite say it as directly, but a great meditation on the question you can look at. Don't think I'm going to get into it now. Um, but understanding that life is chemistry, although it's been influential, um, it doesn't it's not enough, and it's not sufficient. Like, for example, a series of biochemical events can lead to a nuclear bomb being sent off, and understanding that kind of catastrophic set of consequences from simple physiological ones um, isn't likely from a bottom up perspective. It's not going to be a simple explanation. So to actually get at the questions of what are the conditions for life to continue in a sustainable way, for us to actually thrive in a sustainable way, um, it takes a framing which is larger than physiological, at least not looking at the the single individual organism and thinking about the sustaining of its own living condition as the end all of the cause and effect relationships of life itself. So life as chemistry is a narrow and perhaps too narrow paradigm. And these authors emphasize that the role of DNA in biology is a well appreciated kind of information science role for or for this kind of, not role, but like a basis for this kind of framing, for this viewpoint. Or that protein folding, one of my old interests, main interests. The information in protein structure itself, um, from an information processing perspective, is an older view. But there's a cybernetic view that goes further to claim. I'm reading a quote now. A cybernetic view goes further to claim that information processing carried out in the medium of biological chemistry is what life actually is. By information processing, we mean any logical combination of information having the result of producing information, and we shorten this to computation. The idea that living is computing, pioneered by theorists such as Galton in 72, popularized by Bray, but so far it's been constrained mostly to cellular biochemistry and shown up in some neural networks, the area of neural networks. So the analogy, the viewing neurons, analogies between neurons and computations are well known. I think I'm going to pause there and immediately get into um, algorithmic information theory. Although, where's my layers window? There it is. So where'd my windows go? So yeah, algorithmic information theory. Why can't I write on this? Focusing on DNA too much is not okay. So I'm not gonna we're not gonna take too long with this. So again, we're working with this idea that living, specifically being alive, is a state of information processing. This is the proposal of the paper that we're looking at. And what can be obviously seen is that living involves some material processing, that organisms interact with their surroundings in a continuous way, which sustains their living condition. Um, yeah, I'm kind of all over the place, but the the thing to appreciate is that the forward direction in time is associated with complexity being produced only locally. That as living things move forward in time, what they do is take free energy, so organized states of matter from their surroundings, and they borrow that organization to further organize themselves and increase their complexity. So this is a paper from um, William Bennett, the great physicist who's mostly associated with quantum computation at IBM. Um, and in this paper, um, Bennett proposes a measure of information content called logical depth. And I can't get into logical depth today, in part because it's out of my own depth. Um, but it seriously, I lack a lot of the formal skills to completely absorb this paper, even after appreciating it for years and reading a lot of the background things around it. It's rich and large. It's a beautiful, large contribution to put out just for the general public, um, and and it helps a person actually appreciate what the thermodynamics is saying about this information processing picture and how biological systems go about doing their thing. But I am getting distracted from the basic idea here. So without focusing too much on the DNA, let's think about this issue of you have a program, a computer, and a program. And you can appreciate that a computer is a machine and that it's got a series of things built into it. It can do a series of things that are built into it based on what you feed it, what you input to it as a program. And so the program is ultimately going to be reducible to a string of ones and zeros written down on some device. So it's kind of amazing to appreciate, but everything that you're watching on the screen right now, basically everything your computer is doing, boils down to ones and zeros being flipped on and off on a device on the computer based on information that was introduced to the computer through programming. Programs, I guess, can come through the network interface as well, but it's still just ones and zeros at the bottom of the at the bottom. So when you turn on your computer, somewhere on it is written a list of 10110. I don't know. And of course, it isn't actually one continuous string in the way that it's implemented, because there's all kinds of ways that it's broken into words and units that are moved so that it can be moved around conveniently. But it actually it does mean this. I mean, and the information is equivalent to this. So without getting into a definition of information too much, we're gonna just accept for the next little bit that for the next few minutes that information is an actual physical thing that represents a difference between two possible states on a physical thing. So when I wrote this out, it turned into information because you can understand it as two different characters, ones or zeros, that each have their own position in the sequence. In this way, you can map all the operations and all the facts that you would ask a computer to do into a series of ones and zeros that get written down somewhere. So algorithmic information theory works with the problem of, well, I'm not an expert in it, so maybe I'm going to even get this part wrong, but what attracted me to algorithmic information theory is the problem of the difference between information as physicists understand the idea and information as I understand the idea, probably closer to how you understand the idea, as something meaningful. Because the fact remains is if this is the program if this is the program, and then we go, and then we put it into a computer. So that's your input, and then it outputs hello. So apparently, this is a computer program for displaying hello. The problem is, let's say that I just toss a coin. Toss a coin. Heads is a 1. Tails is a 0. So then you toss a coin and it shows up this way. Is this a program? When we tossed a coin, however many times it takes to make a computer program, and then we input that into a computer, does it give you something? If you're like, no, of course not. If you just tried to program a computer by tossing a coin and then putting it in binary, inputting it, then you wouldn't get anything. Then I guess we know that's wrong because we've at least proposed one of them, right? This if you happen to toss exactly this coin sequence, then it would say hello. That's what the program would do. We've already decided what it would do. So this question of programming computers by randomly tossing coins ends up being a rich area that ends up coming up with different sort of measures of information and probability, for example, that are very intuitive. So let's say let's say you toss a coin 100 times and you get toss a coin. Uh, yeah, let's actually go 20 times, something more realistic. So here's a realistic thing that could happen, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so toss a coin 12 times and we get that. So you could say, what is the probability that this happened? And there's one way of counting that. And we can say the probability of this being heads or tails is 0.5, right? It's half heads, half or tails. But probability of this coin toss being heads or tails is also 0.5. It's the same outcomes for all of these. So that one way of calculating the probability is 0.5 to the power of 12, or 1 over 2 to the 12. Um, 2 to the 10 is 1024, so 2048. So it's a small number. It's about 0.00 of you wanted it out, so 0.5. So it's about that. The odds of getting this exact sequence is about that small. But then if we did it again and we got all heads, that seems weird to toss a coin, a fair coin anyway, 12 times and get 12 heads. That doesn't seem right. But the probability of this is also 0.5 to the 12. It has the same probability in terms of calculating this as a sequence of independent events. So is there something wrong here? Is there a paradox? There's something kind of amazing that if you did the 12 coin tosses, every outcome that you get is in a sense completely necessary, but it's equally unlikely as any other outcome that you would get. So algorithmic information theory helps us get at the issue of where does it seem the information is? Where does the intelligible information appear to be? Um, and I can't motivate it more formally. I should study more. But it's related to this idea of what kind of algorithm could generate the thing that you saw. How complicated would it need to be? And so the algorithm that could produce this is really simple. It says H 12 times. So that's a fairly simple description of this program, especially if it wasn't 12 but 120. Then the description of 120 heads in a row is a very simple program. But if you had something like this, this might be maybe incompressible. It might not be possible to simplify this any further. It depends how long it is and what our strategies would be for simplifying it. So if it's 12, then it probably is incompressible, because even if there were little patterns in it, they're not observed enough for you to benefit from removing them and replacing them with another symbol. So the way that we could simplify this would be, for example, if you started defining other symbols, like you notice that there's consecutive heads and consecutive tails. So you said that every time that you have an HH, you replace it with a little h, and every time you have a tail, you replace it with a little t, for example. Then it would seem that you could make this shorter, but you made it shorter by introducing these other rules, and those rules have their own information content. So if you're measuring the amount of how easy it is to describe these two things, this sequence of all heads has low information content. It has a highly self-similar structure. It's a very boring set of things, although it's fantastical if it happened from random outcomes. The information content itself is very low in that process. And so if we imagine what generates all the heads, it's a very different kind of thing than a process which generates the alternating heads and tails this way, or not alternating. I guess that's another example, right? This is something. It might seem significant that it's written this way. But if I kept track of that right, then it's something like HT 6 times. 6 times. So this string and this string, they're almost as compressible because of their self-similarity, the regularity to them. So yeah, without reviewing like all that in any better detail, it just a moment's consideration should show that if you can program a computer with a series of coin tosses, then this question of programming a genome with a number of coin tosses, it shouldn't be so different. And so you would just need to come up with a way to go from base 2 to base 4, essentially, so that if you had, say, heads. That gives you the DNA space A, heads, tails, T, tails, heads, G, and tails gives you C. Now you can take your series of coin tosses and start interpreting it as well, I switched to RNA code there. And if you're the type of organism that has one chromosome in your genome, then it's like almost a perfect analogy. And you might think that, where was that way back here? Yeah, so you might think that in the paradigm where the computer and the program have this input, have this relationship, um, that there could be a similar analogy um, between the so-called body or the let's say a cell and its genome. And so it might not be that interesting to you, but this question of can you take a genome and put it into a cell and then get um, new behavior? It's no longer hypothetical. It's at this point a fairly mature science that's so mature it's turned into a technology, and then there's a whole engineering behind it. Um, and engineering is an applied science. So that biotech is a thing, and that genetic engineering is a thing. Shows that this is like old news at this point, and you can definitely move genomes around from cells, and it changes their behaviors in a way which is analogous to how a same piece of computer hardware will give you different behaviors if you input different pieces of information in the form of different programs. So that aspect of the analogy is just fine. Um, there are large problems with the analogy that you can't get a genome on its own without a cell in the first place is not a small issue. So there aren't like genomes fabricated from scratch by people flipping coins. So that's a very important thing that in all if you do listen to people in synthetic biology talking about their accomplishments, they basically amount to we took apart a cell and we purified its parts, and then we put it back together and showed that when you put it back together, it mediates life processes, and that getting a cell to be alive from parts that were not intrinsically alive before feels like a big accomplishment to the people in that field. But again, all these parts are coming from organisms in the first place, so they're just borrowed from the tree of life and then shuffled around. And it's mostly getting fascinated with this very idea that the living condition itself is the state of information processing, and that the parts themselves are not the living condition. And so really those accomplishments, those small a accomplishments from the synthetic biologists are confirming this, how limited. Um, yeah, the person's asking if this is live. I just noticed the commenter on and yeah, this is live. I can respond to you on the TV, or I can actually type things in. Earlier, Square Balls on Vaughn Live had some questions about well, actually, some objections, I think, with this idea that we can help people by adapting to things, because what we really need is large changes in our organization, which I agree. Anyway, not going to revisit it all. Um, but this programmability of organisms is a demonstrated thing. Whether or not it's like you know, uh, a sufficient description, I think isn't really the point. Um, there's just too much to account for, and there's only one example of this phenomena we're calling um, life on Earth. It's a very specific um, set of set of systems that we're trying to account for. So again, going back to this article from Farnsworth and others, this living as information perspective. Um, the the article reviews information theory, um, talking about the basic information content of pieces of information, how you measure the information content of an object. Yeah, the algorithmic information content, um, citing Chaitin from 1990. So referring to this question of the compressed image in the case of the information content of an image, analogous to what I was talking about before. How predictable is the sequence that we're interested in describing? Um, Gets into biosemiotics, and I forget I forget that in this article takes from Jack Szostak's idea of functional information. I need to read this. Of course, then I have to find it somehow because it's in Nature. Maybe Jack and his buddies at Harvard can help me out. Oh, that search string was too long, huh? All right, I'll do it some other time. But yeah, functional information is to be found in the component parts and the way they're organized into a whole. And that view can be criticized, especially for permitting what appears to be unintended consequences of functions. A frequently cited example being that dirt in a pipe might function as a valve. Right, so that's the etiological theory is the alternative that was developed by Neander. So a function gets its meaning from understanding the context in which it was evolved in. And yeah, so they mentioned ecological systems as a place that doesn't apply. But again, even just this moment where an organism is using a femur, but not to walk, using that femur as an actual tool, that you can call it cultural evolution, or you can start to use different words for describing it. But this is a function that needs to be accommodated in the biological story of this group of organisms. That if this becomes the primary use of femurs in this group, um, including the fact that they still need to walk around, um, that it's a possible outcome, and that it could even be adaptive in some contexts, and that we would need to be able to work with that. So yeah, the difference between things being okay. Actually, no, I got distracted by one of the commenters. But continuing along with this, we can't just explain functions based on the history of things. That's how we get dumb explanations like genitals are to be used for this and not this, or the mouth is to be used for this and not this, um, because of perhaps plausible stories that give biological context for these things being adaptive, but that don't at all account for the fact that organisms get to decide what a function is to them. Organisms get to form their own goals and to direct movement towards accomplishing their own ends. This is point about the reference to Kaufman here. Darwin's theory is a special case of a more generalized principle of selection in which the attribute of persistence is the superset of biological fitness. All right, so yeah, persistence in the natural system is an even better term than fitness. Thus, we tentatively offer a definition of function that is systemic and in the spirit of established etiological definitions, but not reliant on Darwin's theory. Any attribute A of a component C of a system S that causes an effect E. I don't remember reading this before. Such that S persists longer or in a wider range of conditions than without it is a functional attribute of C. Then the functional information instantiated by C is that which establishes A, leading to the persistence in the form of S. Hence the persistence of information instantiated by S. Whoa. That could have been more succinct, maybe, or maybe not. It's a very general language for they're interested in talking about the relationship of an attribute and a component of a system. The attribute is a functional attribute of the component. So this definition lets you deal with both meanings of the femur, because the the vanilla use of a femur is that it's a component of your system, say your leg or your musculoskeletal system, but it causes an effect in terms of bearing forces, transmitting forces, organizing all the tissues, so that the organism persists longer in a wider range of conditions than without it. So yes, it's adaptive to have a functioning leg. It's adaptive to have a femur that's coordinating with the rest of the organism in this way. So this definition explains why things with functionally coordinated femurs persist in the world. Preferring that language rather than is fitter. So it still doesn't really have environment that directly. It says wider range of conditions than without it. So conditions are still being kind of mapped to outside of the system of interest, like by definition here. Um, so then, yeah, I need to find that paper from Shostak. I don't remember. I don't know why I didn't read it. Mathematically amenable definition allows for quantification of the effectiveness with which information enables the system to perform non-random actions, at least one of which will be self-replication. I'm excited to track down that Showstack paper. Effective information for that which causes a persistent change. They use functional information for effective information which supports life. Interesting. So this distinction allows you to track information changes which are maybe even detrimental to the organisms of interest. Um, Non-functional information is continually introduced by random processes, especially at higher, like ecological levels. So non-functional noise may be expected, should be discounted in the quantification of the functional information content. Why isn't that just the effective information? Well, it's not a persistent change necessarily if it's just a random ecological process. I see. There is noise. All right. Well, I can tell reviewing this that I need to read this more carefully because doing it live is making me get all hung up on the actual train of thought. Um, but it goes through some of these definitions of information, which is not unpleasant to read through. The functional meaning of information was defined conceptually by McKay, who referred to information as a distinction that makes a difference. So, for example, a bit. A bit is one or zero, so that's the distinction, and then it makes a difference is part of that definition. Later, Bateson more famously called information a difference that makes a difference, and that idea was taken up by Hopfield, who invented neural networks, I think. Um, In this interpretation, information is defined through its interaction with something, including other information, to create a non-random effect, hence is context dependent. Bates, quoting earlier works, defines information as the pattern of organization of matter and energy. This definition peculiarly addresses effective information. Patterns of organization are the alternative to randomness. Patterns show either order, characterized by symmetry, or complexity, broken symmetry. Hey, and then here's where Schrodinger gets mentioned. Symmetrical order was insufficient to account for the genetic information coding life, concluding that it must be in some aperiodic or non-symmetrical molecule, well before the discovery of DNA. This, so right, Schrodinger isn't talking about complexities, saying aperiodicity is the requirement of the genetic code script. Yeah, that again, that's a great little read that you can find online. What is Life by Schrodinger? I recommend it. To do good, clarifying or just helping me feel secure on my take on Schrodinger, because that is definitely my impression. Um, so then, yeah, figure one. Here we go. Well, I was planning to go through this paper and mostly just leave these figures up and talk about it. Yeah, I don't remember this very well either. This is specifically the mechanisms that they're interested in talking about, the way that information gets organized into the biological complexity scale. Um, yeah, interesting paper. You should find it yourself and read it. To describe life as information, we need a way of describing the functional information without such prior knowledge, recognizing that effect only results from the interaction of information and its context. I don't know how far along this formulation. I don't think this paper actually has some final form of the thing they're proposing. Um, but here's a useful figure. These concentric circles are expansions of complexity. They're not a chronological sequence. So we're not saying that biomolecules assemble into protocells, assemble into cells, colony forming cells. Oh, I guess there is a causal, there's a little bit of a temporal cause chain as you go up there. So they're emphasizing that all of these all these layers exist concurrently at each level, of course. But yeah, natural history of information processing. Hmm. One of the final sections is information processing as an integrated whole. The computation performed by ecological networks is both broader and narrower than that of a Turing machine. A Turing machine is a simple theoretical computer. It is broader because inputs are processed continuously, the outputs are produced continuously, and because processing is sensitive to the environment. Whereas in a Turing machine, processing is blind to all but the initial inputs. Yeah. It is narrower because the computation is equivalent to running a particular model, a model of the system order and control, following the injunction of Conant and Ashby, that every good regulator of the system N must be a model of that system. That's a good thing to emphasize. Every good regulator of a system must be a model of that system. Sounds like a nice cybernetic dictum. I don't remember, but definitely reminds you of the cortical homunculus. Little person mapped onto the brain. Interactions between the biotic and abiotic spheres of the ecosystem are regulated by controls on chemical flows, driven by the processing of materials by life in aggregate. The sum of individual selection and processing actions amounts to a regulation of the whole ecosystem. And so the authors of this paper close with emphasizing that this perspective on life understands life to be continuous to the abiotic universe and the consequence of a spontaneous increase in complexity through repeated combinations of formative patterns such that they give context and dense functions to one another. The processes of life are chemical processes, so our life is information remains compatible with Kornberg's life is chemistry, but goes deeper by highlighting the informational basis of the chemistry of life. Considering life as information processing, computation, where the subject of computation is life, we are faced with a program running on itself, the function of which is to output itself. Such recursion is familiar and much exploited in computer science. It highlights the fact that for life, there is no distinction between the machine and the program. Both are information, they are the same information, ordering and reordering matter and energy so as to persist. It would not be right to think of life as a biochemical structure on which a program is run, because life is the program, and the biochemical structure is its embodiment. That's why we say the information is not just in DNA, but the whole biological system. The idea that life is information processing brings reductionists and synthesis closer together, as it shows life to supervene on chemistry strictly according to information content, but to also possess strictly emergent properties at several levels arising from the functions of the embodied information. Now that functional information content can be quantified on every scale of life, we anticipate its use in further deepening our understanding of life and its place in the physical universe. So, I should read more about this quantification of functional information, probably the last 10 years or so since this paper. But that's a perspective, not reducing the cell to a computer that's operating on the genome, because the cell includes the genome, and it's an important distinction between conventional machines and organisms. So in today's time, I didn't so much put together um, a simple prescription for what to do with this information, with this perspective. And In part, that's because I don't have a very clear description myself. But although I am at the hour mark, um, I'll just finish with a well. Yeah, I won't get into more detail today actually about it, but any description of the function of the organism that doesn't include the context is automatically impoverished, automatically lacking some essential features. And so, as somatic educators, when people are describing their relationships to their functions, you need to listen for context. You need to be sensitive to the ways that context comes along with their descriptions of the functions, if only to provide an obvious learning strategy for them to realize what their situation is and to diversify their actual strategies. And so if a person wants to work on their walking or standing, then we don't work in that context because the thing that they can voluntarily do in that context, we're interested in understanding its information context, its information content in a different context. And so we'll work with standing or walking on the back or uh, sitting or really any context other than the performance one. And so there's something about disengaging from the outcomes, from directing the movements towards the outcomes that sets up the learning context. And it's easy to describe in words. And having a fairly concrete description of what's going on, kind of like how Johann Reierwant describes in Feldenkrais method of teaching by handling in his cybernetic block diagram there. Having an actual concrete description of what's happening in somatic education will help everyone and will make it clearer when something isn't just a diverse application of this approach, but is actually not an application of this approach, is actually something which doesn't really fit the educational strategy of somatic education. And being able to make that distinction will be facilitated by having clear criteria for what functional information is and how teachers can help students and their engagement of it. Um, so yeah, that's one of the axes I'm currently grinding. Um, I might continue on this train of thought next Thursday. Um, Maybe not. Otherwise, you can follow more of my work through my practice at Somatica. Also, starting a newsletter, somatic.substack.com, um, and you can there see some recent thoughts on Schrodinger's paper, or rather, little book, "Life is What Is Life," and related things to somatic education. Thanks for your time, and yeah, resuming the live streams next Tuesday, but not in this vein. Doing review of the various biological structures that are interesting, um, going from nanoscale up to whole parts of organisms in my Tuesday movement structure live stream. Wednesdays, the movement learning. I actually work more on physics and math, currently working through the Feynman lectures in physics, trying to reevaluate my own approach to those materials and my own comfort and self-usage as I refresh my basic physics. And yeah, and then Thursdays I work with the movement organizing theme, somatic education, and as a practice and a movement. See you soon.